Hi folks, it's Warren, back with another attempted board repair. This one is for a friend of mine, Zafex, who bought a Tempest and got it without a working PCB. They sent the PCB separately to me, so I'm going to take a look at it and see if I can get it going. So let's crack it open and see what we've got. Look at that. Okay, what do we got? Yeah, it looks like they may have just taken some pokies off the shelf to populate the board and didn't get it in all the way. That's certainly fixable. Okay, no 6502. So why don't I fix up those pokies and find a 6502, and we'll start with that. Okay, power is all wired up. I've got the scope on in XY mode, so let's see if it does anything. Nope, I'm not getting anything on the screen. In that case, we go back to the basics. We check power, we check clock, and we check reset. Okay, I've got the voltage up to 4.6, which isn't great, but should be enough to get some life out of it. And it's still not showing anything on the screen. So let's take a look with the logic probe and see what's happening on the CPU. There's a couple of clock test points up in the corner. And we are definitely getting a clock, so that's good. And the reset is high, so it should be running. Okay, random lines on the CPU are doing stuff. So I don't know why it's completely dead. Well, I think I'm going to move things along a bit faster by making use of the working Tempest board that I have in my cabinet. Well, as I expected, if I plugged the board set in unchanged, I got nothing at all. Nothing on the screen, no LEDs. If I swap in a known good auxiliary board, all I'm getting are lights on the start buttons. So let's try the other one and see how that goes. Okay, using the new aux board on a known good CPU board does absolutely nothing like we had before. So it looks like both of the boards that we're testing have some kind of a problem. Okay, I don't know why this wasn't coming up before, but it is now coming up in test mode. There's a letter Q, which I believe means one of the tests did not pass. I'll have to look up in the manual which one that is. Let's take it out of test mode. Yeah, okay. So the auxiliary board seems to be all right. And sure enough, Q is a pokey error, audio 2, which is the second pokey. So I will try swapping in a different one and see if this aux board will then work 100%. Well, I've learned a couple more things. I think the reason it wasn't coming up before is that this edge connector is getting a little bit tired. Probably needs to be cleaned. Sometimes I was turning it on and the power light was not coming on. So hopefully that's just the edge connector, because wiggling a little bit seems to make it come back on. But we're still not out of the woods yet, because with the new pokey, when I turn it on in self-test mode, I get this. Well, my bonehead maneuver of the day was to put in the pokey backwards. It's got pin 1 up here when it should be up here. Well, I am now getting intermittent garbage vectors on the screen, so I'm guessing this pokey's not good anymore, and that it's interfering with the bit slice chips. Well, I've had a bit of a setback with the working board. It turns out that 5 low tones and 1 high tone error is actually a vector RAM error. It says that chip M4 is bad. So I went ahead and replaced that, but it still doesn't work. And what I wish I had realized beforehand was that M4 is actually, M4 is the one on the end. That's actually VRAM 0. And I'm always suspicious when the first RAM chip fails, because that means that anything else that's interfering with the RAM shows up as a RAM failure in the first chip. So I've put the formerly working board aside for the moment and went back to the new one that I've been trying to repair. And I found an interesting thing, which is that the interconnect between the two boards was actually offset by 1 pin. There's a broken off pin, and the connector was installed, shifted over 1. So on the far side, it's hanging over. So I've put the interconnect in the right position and put a temporary jumper on the missing pin, and it starts to show signs of life. And I took the EEPROMs out and reseated them, and after doing that, occasionally I can get the test mode to come up. I think I'm gonna, before I go nuts and replace all the EEPROM sockets, I think I'll reflow the connections on the board-to-board interconnect and fix that missing pin. Okay, connectors are reinstalled, and I think the solder joints on the connectors were a factor, because now it pretty reliably comes up in test mode. And it's showing, you can't really read it, but it's showing a ROM error up in the corner. It's showing a Q, meaning a bad pokey. I still have one of the bad pokies in this board. But this is definitely progress. If I take it out of test mode, however, it just watchdog resets. Yeah, we've got 3, 2, 3, 4. So let's look that up and see what that is. According to the manual, only the top numbers matter, and the numbers are 3 and 2. So I have to look at the ROMs at E1 and D1. Okay, D1 and E1 are the 2 ROMs at the beginning, ROM X and ROM 0, and I just lifted those up slightly in the sockets, and now I get no ROM error. So let's take it out of test mode. Ooh, press start. I like the look of that. Yeah, if I wiggle the board, it still resets. And I think what I'll do is I'll thoroughly clean and reseat the ROMs, and then if I get any ROM errors after that point, then I will replace sockets. One of the sockets kind of came apart when I removed the chip, so I may have to replace that one. Well, I cleaned all the pins of the EEPROMs with steel wool, and when I plugged it back in, I got nothing until I pushed on one of the vector generator ROMs, and then the self-test came up, and it's giving me a ROM error 8, which is the one that had the bad socket. So I'm going to start by resocketing the vector generator ROMs and the one that had the socket that came apart when I was removing them. Well, we've plugged everything back in, and it's not looking good. Now I get nothing on the screen, and the CPU read-write is not active, so it's just hanging. But something I've discovered that's interesting is this top ROM is the one that gets accessed first, and some of the data lines on it don't appear to have any data on them. They're just floating lines. So let me try swapping in an EEPROM from the other board and see if that helps. Well, this chip appears to be behaving exactly the same way. Some of those lines show up as floating. If I measure the voltage with a meter, it's showing up as 1.5 volts, so that makes me think that something else is pulling the line low and is fighting with this chip, which is trying to pull it high. So I'm pretty sure this bus receiver is bad. Well, I replaced the buffer and no change. Same strange behavior, and then I realized it's probably a shorted data line. And so I checked between the data lines and found two that are shorted together. So now we gotta fix that. Well, I pulled out my nice new socket, and it looks like there might be a short on the second to the bottom pin on the left, to the trace that runs right next to it. So I straightened it and tinned it, and now it's not shorted, so hopefully we'll be back to normal once I put the socket back in. Well, booted up, and I've got a ROM error code 2. ROM error 2 was the first one in the set, and I just pulled it slightly out of the socket, booted up, and no error. Well, I've had the dawning realization that I've had a lot of problems that are socket related, so I think it's time to just replace as many of these sockets as I can. Unfortunately, I've only got 6 more sockets available, but I'll start with the 2 that definitely had ROM errors at one point and go as far down the line as I can. Some of these look a bit nasty. You can see some just gunk and corrosion. I'm not sure exactly what that is, but it can't be good, so it'll be good to replace these. Okay, we have 6 shiny new EEPROM sockets. Let's fill them up and see what happens. And self-test comes right up. No ROM errors. So I think at this point I will call the main board good. So now let's put the original auxiliary board back on with a couple of good pokies and see how that does. And it comes up with the original aux board. I'm getting an error code E, which is the EA ROM, and that could just be because of the power supply I'm using. But I think what I'll do is I'll plug this into the cabinet and see how it does there. I don't know why, but for some reason in the cabinet it is playing blind. Nothing on the screen. I'm going to put that aside for the moment and look at the cabinet again later. So I'm back onto the first board, which was working and now gives a 6 beep RAM error. And what I've been trying to do is figure out what other than the RAM chip could be at fault. So if I remove the ROMs, then nothing should be trying to put data on that bus except the CPU when it's trying to write to the RAM, and then the RAM when it's trying to read from the RAM. So I removed the 2 ROM chips, and of the 4 pins, data pins on that chip, 2 of them are stuck high. And then pulsing. If I look at the other 4 bits on the chip next to it, all 4 of those are pulsing. So I'm beginning to suspect this vector generator data buffer coming from the main CPU is not letting some of the bits in. So time to hook up the logic analyzer and see if it's doing what it should do. Okay, I have the logic analyzer hooked up to the buffer IC. The top 4 lines are coming from the CPU, they're all low. The next 4 lines are supposed to be the same thing being buffered and sent to the vector RAM, and the first 2 are low, but the last 2 are high. And down at the bottom you can see buffer is enabled and write is enabled, so it looks like this chip is not passing those 2 bits like it's supposed to. Okay, I replaced the buffer chip with a new one, and sure enough, it comes back up again. Things are running. So, disaster averted. But there's one more small thing that I need to check. For some reason, the 15-volt regulator for the vector outputs is only putting out about 7 volts, and it's not getting warm, so it's not overloaded. So I think just the voltage regulator itself went bad. So I'm guessing I must have had just a power spike on the harness when it was loose. That damaged the buffer IC and damaged the voltage regulator. Okay, the new regulator is in, measures as it should, and the display is coming up nicely. I installed the original pokies back in this board, and they both appear to be working. There's no errors in the self-test. So even the one that was unfortunately plugged in backwards is still working okay, which was a nice surprise. So my Tempest is back to normal, so let's see if we can finish up the one we've been trying to fix that started all of this. So the last remaining issue with this board is the EAROM error, the high score chip. And I was hoping it was just a matter of replacing the EAROM chip, which is this one here. So I tried installing a new old stock EAROM chip with the same problem. Still comes up with error code E. So I put the original chip back in, and my guess was it would be some kind of a power issue. This chip runs on a rather large negative voltage in order to do its writes. In Tempest, it runs at minus 28 volts, and there's a circuit on the board that generates that minus 28 volts, which is up here. I measured it, and sure enough, it's got about minus 2.8 volts on it, so it's not doing what it should. So I started poking around in the circuit a bit, and I noticed that there are 2 components that are missing. These are 2 diodes that are in what they call a charge pump circuit. This is the power circuit for the high score memory chip, the EAROM. And all of this is present on the board except these 2 diodes. And the circuit does basically nothing without those diodes. So I can only assume that I have to put them back in. And that's what we're going to try next. I didn't have any of the correct diodes on hand, so I had to use my Space Duel donor board. And this is where I took the diodes out of. So I'm kind of wondering if maybe that's what happened to this Tempest board before. Somebody needed a couple of diodes and just pulled them. But I do plan to put these back later once I get some more diodes. So the diodes are in, and the connector is reflowed and cleaned and looks good. So I think we're ready to give it a try. Self-test shows no errors, no ROM errors, no pokey errors, no EAROM errors. It's looking good. So let's take it out of test mode. And it's set for free play, so let's give it a try. Yeah, looking good. Well, for some reason it's still not saving scores. It passes the tests, but scores won't save, and I even tried putting in a new EAROM chip again, and that didn't help. So there's still something afoot. Well, I seem to have hit a bit of a setback. In the process of trying to troubleshoot the EAROM that wasn't working, I was looking at things both on my board and on the board in for repair, swapping EAROM chips and things like that, and I now get the EAROM error on both boards. Okay, I finally have a theory as to what's going on with at least one of the Tempest boards. There's a series of control signals that the chip uses, some data lines and some address lines. And I poked around with a voltmeter and a logic probe and eventually figured out all the lines were changing except for one of them, which was a C1, pin 15, was stuck low. And I looked back at the chip that is driving that, and it has 2 outputs. That goes to pin 11, which is a Q bar. There's also a Q output, which is supposed to be the opposite of Q bar, and they were both set to low. So it's just stuck. And I realized that pin 15 is right next to pin 14, which is the minus 28 volts for powering the writing to the chip. And I can only assume that I dragged the multimeter probe across the 2 pins and shorted the minus 28 volt onto this data line, which then burned out the output gate on this flip-flop. Okay, I replaced the flip-flop and things are better, but we're still not quite there yet. That pin that before was just stuck low, it now tries to go high at the appropriate times, but the logic probe shows it as indeterminate. It doesn't show high or low, and the voltmeter shows it as 2.49 volts. So something is still dragging that line down. On the schematic, you can see that that clock 1 line has this other chip attached to it on one line. I clipped that pin, and with that chip disconnected, the line goes fully high. And so if I just replace that F3 chip, hopefully we'll finally be done with this one. Okay, the new chip for F3 is in, a 74LS374 is installed, and I no longer have an EAROM error. And we're looking good. I played a game and saved a score and powered off and powered back on, and the score is there. So I think this Tempest board is finally back to normal. So let's see what we can do with the other one. Okay, back onto the new board, and I got it hooked up, and you can see it does have the E error code. Checking it out with the logic probe, and the obvious thing to do is check for the same problem that the other one had. And I did that on this flip-flop where the data for that control line comes from. One output is low, and the other output is also low, and that's not supposed to happen. They're supposed to be the opposite of each other. So one of them is being stuck in the wrong position. Now it's possible that this chip itself is bad, it's not putting out the correct signal, or that something else is pulling it down, which was, both of those were the case on the other board. But what I'm going to do is remove the EAROM chip and clip the pin on the other IC that went bad, and then see what kind of output I get, see if the output looks correct. I'm guessing I'm going to have to replace this, so I don't feel too bad about clipping it. The lead that I clipped is 54 ohms to ground, so that's definitely bad. Alright, we got low and we've got high. So this chip is actually okay on this board. So we got to replace F3 again. Okay, I think I finally know what's going on. This clock signal on my now good working board that toggles twice during startup, the second time just before the self-test screen appears. And on the board that's still throwing the EAROM error, that line does not toggle. And I checked on the flip-flop that comes from, and there's a complementary Q-bar output on pin 6, and that one does toggle. But pin 7 is just stuck low. So I think it's a bad output on this chip again, which is the same one we had problem with on the other board, but it was this output that went to, actually this pin 11 that went to C1. But this clock is also on an adjacent pin to the power. It's on pin 13 instead of pin 15. The 28 volt power is right in between on pin 14. And we're still not quite there. It passes the test, but doesn't actually save scores. If I go into the test menu, press Fire and Zap for self-test, it will show no errors. There's no EAROM error showing up here. But when I take it back out of test mode, my scores weren't saved. Well, we're running out of things it could be, so I hooked up the logic analyzer to what's left to take a look at. And what I've actually done is connect it to this chip here, E3, which is the buffer that takes the output from the EAROM and sends it back to the CPU. And what I found is these are the top 4 bits of the input of it, and these are the top 4 bits of the output. And the highest bit is always low, which is wrong, because over here there's pull-up resistors, so all of these should be high. If this isn't here and this isn't here, they're going to be pulled high by this, and one of them is measuring low. And the new chip is installed. Let's put the other two back in and see how it does. Nope, the battle continues. Well, I think I finally caught a break. I'm measuring the clock signal to the EA-ROM and one of the data lines, and looking at them on the scope. The top is the clock, the bottom is the data line, and the clock is only reaching about 1 volt. It's supposed to be a 5 volt signal. Well, it's actually the flip-flops that I replaced before. I got some brand new ICs in, got them installed, and I've got a nice strong looking clock signal, and it's still not giving an EA-ROM error in the self-test. So let's see if we can save some data. And there we have it. Scores are finally saving. I powered it off and powered it back on, and score is still there. Sound works, everything seems good. I think we're finally there. So let's just get a few more things cleaned up, and we'll be done. While I'm putting new components in, I thought I'd mention the pokey chips. The only ones that I could get are socketed poles. So these were desoldered from something, probably Atari 7800 ball blazer cartridges. One or more of the leads broke when they were removed, so they're now, to make them usable, they've been soldered into a socket. And that works great. A lot of people do that, but I don't like it because the pins on the socket are larger than the pins on the IC, and it tends to stretch out the socket on the game board. So what I actually did is used a hot air station to remove the pokey chip from the socket, cleaned up all the solder that was on the pins, straightened them out, and added just pieces of resistor lead to onto what was left of these pins. Goes right in, and no harm done. And we've also decided to do a capacitor kit. The caps are installed on the main board, and I also installed new potentiometers for all the vector adjustments. And there's the new caps for the aux board, and the old caps for the aux board. And the new diodes are in. I didn't have any germanium. They're actually kind of exotic a little bit these days. So I just put in some silicon switching diodes, which have a somewhat higher voltage drop, but there's still plenty of voltage. Just as I was finishing up and doing some final testing, I discovered a strange and rather worrying problem. If I left the game running in test mode for an extended period of time, there was an M mathbox error that wasn't there at power up. So I was concerned that there was some subtle, obscure hardware problem that was going to be very hard to track down. Eventually, I figured out that it was doing it very consistently after 10 minutes, so I could hit the reset button, and every time, 10 minutes after I did that, the M would show up. So whatever it was encountering was something that happened regularly, so it wasn't just some completely intermittent, flaky thing. So I started swapping around boards and cables and things, and eventually discovered that both boards were doing the same thing. That made me think that it may be a glitch that happens to all Tempest boards of a certain hardware and software revision, although I couldn't find any mention of it on the internets. It didn't seem like anybody had encountered this before. The final thing that allayed my fears and made me realize it was okay was that if I run the Rev1 ROM set in main, that shows the M error as well. So apparently it's just a bug in the early ROM revisions of Tempest. I think we finally got everything working, and I'm very happy to send this board back all cleaned up and tightened up and as bulletproofed as I can make it. And hopefully mine will continue to work just fine as well. So I hope you found this interesting. Thanks very much for watching, and look for more repair videos in the future. Now, let's see if I can get this back in without wrecking it.